morning to everyone. Today we are going to see about scale, and there I have divided the scale into two parts such a way you can easily understand the concept without watching the lengthy video clip. Okay, so without wasting any time, let me get inside it. First one, we should know the representative fraction. Before that, let me tell what are the scales we are going to see. Symbol scales and diagonal scale, vernier scale, three scales we are going to see. And before that, we should know what is representative factor. Hereafter, I will call this one as a RF. Okay, actually RF is nothing but a simple calculations, the length of the drawing divided by actual length of the object, because whatever the object we are going to see, we are going to make them and we are going to make a small drawing in our sheet, whether it's A0, A1, A2, A3. So we are going to reduce the scale and we are going to fit everything within this paper itself. For the purpose, we need to know what is the representative factor. Okay, for example, 1 mm long edge of an miniature object is shown in the drawing by a line of 1 centimeter long. That means 1 centimeter, which is divided by 1 mm. So actual thing. Okay, so then you have to go for the unit conversion, because one is in the centimeter, another one is in the millimeter. So we have to convert into units. So 10 mm divided by 1 mm, because 1 centimeter is equal to 10 mm. So we are getting the ratio of 10:1. Let me see one more example, and this one is enlarging scale. That means the actual picture is this much big, but when you are going to draw, and it's going to be like this much big. So we call that as an enlarged version. So enlarged versions are very much helpful. So many things, like such example of tissue culture, because in the human cells you cannot see with your naked eyes, but when you are going through the optical microscope or you are using any lens, you can easily identify what are the things are placed inside. So enlarging scales are available in the world. Okay, and let us see 1 kilometer length. Next example, 1 kilometer length of road is represented by 1 centimeter in a drawing. Okay, then RF will be 1 centimeter divided by 1 kilometer, and for the unit conversion, 1 kilometer is equal to 1, and you have count the zeros. Then we have the ratio of 1 is to this much. Okay, that is called reduced scale. So reduced scales are having so much applications, not only this automobile chassis, but also the globe is very big, but when you are going for printout, with you can print the map of the globe. It's a 1 A4 sheet or A3 size. Okay, that is also called reduced scale. Okay, so for making this diagram, we should go for the standards, and making the diagrams very easily and meaningfully, we are using this RF. Okay, so there is a value. If the value is equal to 1, then we call that the full size. If the scale is such as take x, which you are taking, that is ratio is x is to 1 for enlarged scale, and reduced scale 1 is to x is very less, whereas x equal to always greater than 1. Okay, follow these rules, you will get. First, we will go for the plane scale. A plane scale is simply a line, as mentioned over here, which is divided into meter as well as decimeters. Okay, it's got only one subdivisions into small parts. So you may connect kilometer to hectometer, meter to decimeter, centimeter to mm, not more than that. Only 2 units it's going to cover, not much more. So let us see what is the plane scale. So in the plane scale, we have the 4 meter and 6 dm decimeter has been measured over here. That is 4 meter means 0 to 1, 1 meter, 1 to 2, 2 meter, 3 to 4, 3 meter, 2 to 3, 3 meter, 3 to 4, 4 meters. Actual length is 5 meters. So 4 meter, 6 decimeters. That means from this scale, we have to go towards this direction. Let me draw one line so that you can. So we have to move towards this direction, whereas this is, and this little bit big is 5. That means this is the 6th one. So you will get a reading of 4 meter plus 6 decimeter. Now we'll go and draw the items. Let us see the problem. The distance of 1 meter is represented by a line of length 2 centimeter on a drawing. Draw a plane scale to show meter and decimeter and to measure up to 6 meter and indicate a distance of 4.5 meter on it. That means the overall scale what we have to make is for 6 meter, and from that we are going to measure only 4.5 meters. That means 4 meter and 5 decimeters. For taking the RF calculations, they are already given the detail in the first line. So let us determine the RF. That is 2 centimeter, which is going to be drawn in the line in your drawing book, but actually the length in 1 meter. So as usual, you put the values over here, then curve for the unit conversion. 2 centimeter, 1 meter is equal to 100 centimeters. Then you will get the fraction 1 by 50. Now we have few more calculations we have to do. The obtained length, how much means it's 6 meter we want to represent. So how much centimeter it was, we have to do the calculation. So the RF into given length 6 meter. 6 meter means 600 centimeter we have to keep. So when you are going for small calculations, you will get 12 centimeter. Now you take your scale and measure 12 centimeter and make one box like this. Height of the box, it's up to your wish. 3 centimeter, 4 centimeters also you can take, there is no problem. But the length, let me show it in the laser point. This length, overall length should be 12 centimeter, and we have a measure up to 6 meters. So we divide this length into 6 equal number of parts. First one here, second, third, fourth, and we have the 6 divisions over here. So 1, 2, 3, 4, 5, 6. Okay. Then we have to keep 0 over here. Why we have to keep 0 over here? It may be start from here, right? So let me tell you, here after the right side, for me the right side, let me show the pen. This side with scale will give the meter, and we have the decimeter, right? So that will be present over here. Okay. So for the purpose only we are having 0 over here. Okay. Then give the name 1, 2, 3, 4, 5. Okay, 5. Then this 0 to this side, right? We have to divide this into small segment, which is equal to 10 equal parts, right? So make one inclined line, you know what is the angle, and take a canvas, cut 10 arcs, then you connect the last one with the 0, and so on, go ahead with parallel lines. So there these lines are crossing this here, right? So you make a vertical line on it. Now we have the decibel for 10 divisions. Okay, so next just give the name 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so decimal scale is over. Let me take the eraser and erase this thing. Okay, now decimal is over. Give the name meter scale, decimeters. Now we have to measure 4 meter, right? So RF values just write over here, and let me, 4 meters means here to 1, 2, 3, 4 and 5 units in the decimeters will give 4.5 meter. So this is the plain scale and very simple one, easy to understand. This is a concept of scales. Now we will go for another one, is the diagonal scale. So in this diagonal scale we are going to measure the 2 units such as meters, plain scale, it's about plain scale, 2 units. What about beyond that? So we are using the diagonal scales to represent 3 units such as meters, decimeters, centimeters, or decimeter, centimeter to millimeter. Then we will go for it. Okay. Now this diagonal scale always will be like this only, meters this side, decimeters here, centimeters on the diagonal divisions. Okay, let me see how to do. Let us take a small divisions. It is AB, it's a horizontal line. Now make one lengthy line. Okay, and diagonal line you are making. So connect the diagonal. From that you have to make 10 small divisions like 1 to 10, and you have to connect 1, 1 dash, 2, 2 dash in the diagonal line. So we are having 10 divisions over here. So the triangle of 1, 1 dash to C will always having a equal to 0.1 times of AB. So on, if you are going, that is 2, 2 dash, which is equal to 0.2 times of AB. So on, if you are going 9 dash will give 0.9 times of AB. Okay, now the principle is used for construction of diagonal scale. Let us take the problem. A square area of 16 centimeters square on a map represents a square area of 1 kilometer square. So normally if you are opening the Google map, it will give one small scale. This much length is 2 kilometers something, right? This type of one. So find the RF of the scale of the map and draw the diagonal scale to show the kilometer, hectometers and decameters, and measure up to 3 kilometers. Indicate as a scale distance 1 kilometer, 6 hectometers and 5 decimeters. Now solution, first we have to find the RF value. 4 centimeters, which is going to be shown as a 1 kilometers, that means 16 centimeters square. So that means 4 into 4 will give 16 centimeters square. So 4 centimeter by 1 kilometers. Now we have to go for the unit conversion, that is 4 centimeter. So here 1 into 10 power 5 centimeter, so which is going to give the ratio of this one. Now we have the measuring up to 3 kilometers. So RF into measurement length, that is 3 kilometers. So 1 by 25,000 into 3 kilometers. Again here you have to go for unit conversion, which is in the centimeter scale. So we will get 12. Okay. Now here we have to construct the same type of box arrangement, and you know what will be the divisions. So here 3, as you can see, we are going to measure up to 3 kilometers. So I am going to divide the 12 into only 3 parts over. Now again that measurement start from 0 here, 1 as well as 2. Okay. Now previously we have made in the bottom side. This time we are going to make top side. Diagonally we are going to make one line, and you know that angle, and divide into 10 equal number of parts. You connect the last one with the 0 line, and parallelly you draw this line and give the names as usual. And you know this is a 5th one, so that only this line is getting bigger. Okay. Now I am going to divide this into two numbers, 0, 2, then 4, then 6, then 8, then 10. Because if I putting 1 to 10 means more counts will come here and it will give some disturbance. That's what. And next we are going to keep this is a and this is a C. And remember the diagonally how we made the lines. Now diagonally we are going to make one line, and we are going to connect that node to, first dividing is into 10 equal parts, and we are going to connect that into C. Okay. So on parallel lines are we are going to do on AC scale. Already C to 0 scale we already finished. Now give the names 1, 2, 3 on the vertical lines, and dash lines you have to give in this side. Okay. And after making this mark, we have to make the horizontal lines like this. 10 counts already we did. Now we are going to measure A and B. This not measure, we are going to name this as a B, and we know the diagonal scale, which is A, B, C. No, so you connect A, B, C. Now A, B already in the same line, so C to B only we have to connect. Right. So after connecting this one, diagonally we have to draw the line from the remaining points. Right. Now we have to give the names kilometers, hectometers and decameters. Okay. Now our aim is we are going to make 1 kilometer distance, this is, and 6 hectometers. Okay. So 5 we have to make, right? 165 we have to make. So 1 kilometer is over. 6 count means here you are going to start 0, 2, 4, 6. So exactly if you are going here, we will get the 6 count. So what about the 0.5? That is 5. Okay. So that you have to measure in this diagonal scale, which is coming in the horizontal line. Okay. From that we are going to measure, and we are this is a diagonal line where it's cutting. From that we are going to make one vertical lines, and from the 6 to this vertical line distance is 5 decimeter. So decameters. So this is how we are going to calculate, and we are going to finish the scales for diagonal. Okay. Now thanks for watching.